Welcome back to West Virginia. Okay, are you ready for joke of the day? Of course you're ready for joke of the day because it is the best part of the day. So how does NASA organize a party? Well, they plan it. All right, let's plan our own little party, our composition function party. So we're going to talk about composition functions, also called composite functions. You'll hear them interchangeably. So the composition of the function of f with g is denoted by, and this is not fog, it's actually f of g. And so whenever you see what looks like fog, you should read it as f of g, and it's defined by this. And what this simply denotes is f of g of x. Now when you see this notation, what you should be thinking is, I'm going to take my f function, and everywhere I see an x, I'm going to put the g function in it. That is what f of g of x simply means. Take my f function here, because it's on the outside, take that entire function, and everywhere I see an x, put this one that's on the inside of it. And that is what a composition, also called a composite function, means. Because I am making composition where I'm plugging one into the other. So I've got 3 examples that we're going to be looking at. In each of these examples, we're going to get our fog, our f of g of x. We're going to get our goth, our g of f of x. And then we're going to take our f of g of x and evaluate it for 3. We're going to take our g of f of x and evaluate it for 3 as well. So in this first example, here's my f function, here's my g function. So in order to find my fog, my f of g of x, remember what that indicates, and this is the easiest way to go about it. Take that f function, because it's on the outside, and put my g function inside the f function everywhere I see a g. So that means, here's my f function. I have an x right here. I'm going to take this g function, I'm going to plug it in for that x. So instead of 5 times x, it's now going to be 5 times this, 2x plus 3. And then I'm going to take the rest of that f function plus 9, and there it is. Now I'm going to evaluate it. So you know that when you evaluate this, you're going to distribute your 5 through, giving you 10x plus 15 plus 9, and 10x plus 15 plus 9 is simply going to give me 10x plus 24. So that is what my fog is, f of g of x. Now I'm going to do at g of f of x, my goth. And remember what g of f of x means is, take my g function, and everywhere I see an x, put the f function in its place. So here is my g function, and there is my x. So I'm going to take this f function right here and plug it in where I see that x. So instead of 2 times x, it's now 2 times all of this, 5x plus 9, plus that 3. And you know that when you evaluate that, you distribute your 2 through and get a 10x plus 18 plus 3. And then 10x plus 18 plus 3 is 10x plus 21. And that is my goth, my g of f of x. Now remember, I was told, okay, let's take our fog and let's evaluate it for 3. There are a couple of ways of doing that. One way is to say, well, I already figured out g of f of x, or f of g of x. So I'm going to take this, my f of g, here, and I'm just simply going to put a 3 in everywhere I see an x. So I'm going to put a 3 right here. That'll be 10 times 3 plus 24. And 10 times 3 is 30. And 30 plus 24 is a 54. So therefore, my f of g of 3 would be 54. And then I was told, let's take my goth, my g of f of 3, and evaluate it for 3. I would do the very same thing. I already got g of f of x. So I'm going to take my g of f of x and put a 3 in there. So instead of 10 times x, it'll be 10 times 3 plus 21. And 10 times 3 is 30. 30 plus 21 is 51. And so that is my GOF, my G of F of 3. It would be 51. That's one way to do it. Another way to do it is to say, well, I think instead I'll take this and I'm going to take my 3 and plug it in my G function, take that answer and plug it into my F function. If I do it that way and I do G of 3 and plug 3 in here, 2 times 3 is 6, 6 plus 3 is 9. Now I'm going to take my F function and plug a 9 in there. And that means put a 9 here. 5 times 9 is 45. 45 plus 9 is 54, which is exactly what I got previously. And if I wanted to handle it that way for G of F of 3, that means put a 3 in F. So put a 3 here. 5 times 3 is 15. 15 plus 9 is 24. Yes. And then put a 24 in here, which means put a 24 right there. 2 times 24 is 48. 48 plus 3 is 51, giving me the very same answer. So either way is perfectly fine in terms of getting or evaluating your composition function for a particular number. Now let's take a look at a couple more examples, just because I like for us to feel very confident about what we're doing. And yet again, I'm told let's get f of g of x, g of f of x, f of g of 3, g of f of 3. So to get my fog, f of g of x, remember what that means is f is on the outside, so it becomes my big function. I'm going to put my g of x function inside it. So here is my g function. I'm going to take that, I'm going to put it everywhere I see an x. The problem is see an x twice in my f function. So that indicates I'm going to take this and put it in here, and I'm going to square it. But then I'm going to plug it in here, and I'm going to distribute a -4 through. And then I'm going to evaluate this. So when I square this, that's going to indicate 3x squared plus 1 times another 3x squared plus 1. And then I'm going to distribute that 4 through this one and get a -12x squared minus 4. I'm going to FOIL this to get a 9x to the 4th plus 3x squared plus another 3x squared plus a 1. And then I'm going to subtract my 12x squared minus my 4 and combine up all my like terms. The x to the 4th won't combine with anything. 3x squared is 6x squared. 6x squared minus 12x squared is a -6x squared. And I don't have any x to the first, but 1 minus 4 is a -3. So here is my f of g of x. And now I'm going to do g of f of x. My GOF. And remember what this indicates is g is now my big function. I'm going to put my f function inside of it. So what that indicates is instead of doing it this way, now what I'm going to do is take this f function here, plug it into the g function. Now fortunately I've only got one spot to put it in. So when I put it inside this function, now I'm going to square that f function and combine it with everything else. Order of operations says do that squaring first. So that indicates x squared minus 4x times another x squared minus 4x. And then I'm going to add that 1 in the end. I'm going to go ahead and do this. I'm going to FOIL and then distribute my 3 through, giving me x to the 4th minus 4x to the 3rd minus another 4x to the 3rd plus 16x squared. Don't forget that plus 1 in the back. I'm going to combine my like terms, which would be a minus 8x to the 3rd. I'm going to go ahead and distribute my 3 through. We'll bring that back up here in just a minute. When I distribute my 3 through, I get 3x to the 4th minus 24x to the 3rd plus 48x squared. And then I'm going to combine up those like terms. X to the 4th won't combine with, oh, they are. I already did. Oh my goodness. There's nothing that will combine. So this is my g of f of x. Now at this point, remember I was told let's go ahead and get that g or f of g of 3. And we said there's a couple of ways of doing it. I've already not evaluated, but I've already simplified that. So I can simply take this and put a 3 everywhere I see an x. Follow the order of operations. 3 to the 4th power is an 81. 3 squared is a 9. 9 times 81 is 729. Minus 54 minus 3. And let me speed myself up just a little bit here. That will give me a 672. And that's going to be my f of g of 3. F of g of 3. But remember, I also could have said, well, this is indicating that I'm going to take my g function, put a 3 in there. 3 squared is 9. 3 times 9 is 27. 27 plus 1 is 28. And then put that 28 in here and here. Square the 28. Multiply 28 by 4 and do that subtraction. Either way, I'm still going to come up with a 672. Now, I also need to get my g of f of 3. And remember, I can take this and I can simply plug a 3 in there. And then follow order of operations, which once again says, let's do the exponents. 3 to the 4th is 81. 3 to the 3rd is a 27. 3 squared is 9. And here again, I'm going to speed myself up a little bit. When I do this multiplication, I get a 243. This multiplication, I get a 648. This multiplication, I get a 432. And when I combine all of these up, I get a simple little 28. So my g of f of 3 is a 28. And once again, I can go this way, or I can say, well, this means put a 3 in here. Put it in the f first. 3 squared is 9. 4 times 3 is 12. 9 minus 12 is a negative 3. Take that negative 3 and put it in here. Negative 3 squared is 9. 3 times 9 is 27. 27 plus 1 is a 28, which is a little bit easier than what I did right there. Sometimes it's easier to plug it in this result. Sometimes it's easier to go back to the beginning, and it just kind of depends on the situation. All right, let's take a look at one more. Flip this thing around. One more example. Enjoy that scenery while I get this thing cleaned up. And in our last example, we have our f function is going to be a square root of x. And our g function is going to be an x plus 2. And same directions. I'm told let's get my fog, my f of g of x, which indicates take the f function, put the g function inside of it. So I'm going to take this g function right here, plug it inside the f function everywhere I see an x. Basically that means I'm going to take a square root of all that. And there is no way to simplify that. So that is my f of g of x, because there's nothing more that I can do with it. Now I'm going to get my g of f of x. And g of f of x, remember what that indicates is I'm going to take my g function and put my f function inside of it. G is the big function, f goes inside of it. Here's my f function. I'm going to put it inside the g function right there. So that means when I put it in there, I'm going to put a square root of x right here and add a 2 to it. And there's no way that I can combine those two, so there's nothing that I can do with that one. It's as simplified as well. Sometimes they really are that easy. And now I'm told, all right, let's take this f of g, and let's get f of g of 3. And remember, there's a couple of ways of doing it. I've already evaluated f of g of x, which is right here. That means put a 3 right there where the x is. So if I do that, that just simply indicates, let's do 3 plus 2 and get a 5. So my f of g of 3 is simply going to be a square root of 5. Or I could put a 3 into the g function here. 3 plus 2 is 5. Take that 5, put it in here. I'm still getting a square root of 5 either way. And now I'm going to do my g of f of 3. Once again, a couple ways of doing it. I've already evaluated g of f, which is a square root of x plus 2, and that means put a 3 right here. So that would be square root of 3 plus a 2, which I cannot put together. There's nothing more that I could do with that. So that is, right there in one simple little step, my g of f of 3. Or I could put the 3 within the f function here, giving me a square root of 3, which I can't do anything with it. It is just a square root of 3. That's as simple as that one gets, and yet staying exact. And then take that square root of 3 and plug it in here, giving me a square root of 3 plus 2, which I cannot put them together. So hopefully what you're seeing with these composition, or also called composite function, is it's a composition putting one inside of the other. The way that you determine which one goes inside the other, this one that comes first is your big function. And so what I always do is write it first and put my parentheses, take this one and plug it inside of that. This way that it's written makes it easy to understand. This way of writing is very challenging to understand what goes inside the other. So I always write it this way and make this very small so that I can see, oh, that one goes inside of that one right there. And then in terms of evaluating for a particular number, you can either go with what you had evaluated for your f of g of x or your g of f of x, or you can go back to the beginning, either way you want. So I hope that helps. Have an awesome day.